Solving radical equations has 4 steps in my mind. First thing you do is isolate the radical. You make sure everything is away from the radical, or if you have 2 radicals, put one on one side of the equation and one on the other. Then you square each side and get x by itself from there, and then you check your answer. And you have to check your answer because a lot of times, well, it's good to check your answer because you might have messed up, but it's also important with radical equations because when you square a principal root, you often come up with solutions that are called extraneous. They're solutions that really don't solve the equation, so you need to check your solutions to make sure that they all work, because they might not. So let's do the one on the right first. I already have the radical by itself. There aren't any numbers added or multiplied to it. And so let's go ahead and do the inverse operation of a square root, which is to square both sides. So I've freed the 12 minus x from its root. And then on the right side we have 0, and 0 squared is still 0. Then I get x by itself, solve for x from here. Not too bad. I'm going to actually add x to the other side because he's negative and I don't like him to be negative. And then we've got 12 left on the left side and x on the right side. 12 equals x, or x equals 12. Okay, cool. So let's check it and make sure it works for sure. So we have rad 12 subtract whatever x is. Well, I found the solution that x is 12, so plug that in, and do we get 0 back? Yes, because 12 minus 12 is 0, and the square root of 0, the principal root of 0, is 0. Check. So, answer 12. Okay, now let's do the one on the left. First thing, isolate the radical. Well, I've got 12 added to the front of it, so I'm going to subtract 12 so that I've got everything on the other side that's not under that radical. So we've got rad, because that's gone. 2x minus 1 equals 4 minus 12. Well, that's negative 8. Alright, so now, second step, square both sides, the inverse operation of a square root. So square and square. Well, I freed the 2x minus 1 from the radical on the left, and on the right we've got a negative 8 times another negative 8. Well, that makes positive, and I'm going to put positive just so that you don't forget and put a negative there, positive 64. And then let's get x by itself the rest of the way. We already did the biggest thing, got it out of that square root. So I'm going to move the 1 away from it. Got 2x equals 65. And then one more step, get rid of a multiplied 2. Multiplied 2 is to divide by 2. Alright, so we get 65 halves. But let's check to make sure it works, because it may be an extraneous solution. So I wrote my check over here and plugged in 65 halves, and because I multiplied by a 2 out in front, that really wasn't too bad of a thing to have. A fraction wasn't too horrible. Cancelled out and left with 65, take away 1, all the way down to 20. Well, 20 is not the same as 4, and that is what I was supposed to get from my original equation. So the solution I found doesn't work. Now you might think that's crazy, but it makes sense that we wouldn't have a solution to this equation. You go all the way back to when we were up here and we said, oh, the radical of a 2x minus 1 has to be negative 8 before we squared both sides. That doesn't make sense because the principal root is always positive. So for me to say that this principal root, even though I don't know the value of it yet, to say that that is a negative value, it's not. It can't happen. And so that makes sense. There wouldn't be a solution. And if you saw that right at the beginning, then you would know that there isn't a solution. But we've done so many that it's hard to catch things sometimes. And sometimes that isn't the case, and you do get an answer, and so you need to follow those same steps of isolate the radical, square each side, solve for x from there, and then always check your solution.